This is one of my favourite things to talk about, and that's how to tackle nuclear equations. So what happens to an atom when alpha or beta are released from the nucleus? How does it change, and what do I do? Just like in maths and chemistry, we use equations to represent nuclear decay, and they're called nuclear decay equations. We've previously spoken that alpha is represented by 2 protons and 2 neutrons. So therefore, it's got 2 protons just here, and then the 4 here is the 2 neutrons and the 2 protons, which add up to 4. You should also remember that an alpha particle is a helium nucleus, and that's why it's capital He, just like you see it on the periodic table. So this is an example of a nuclear equation. We've got radon on the left with 86 protons, and the mass number is 219. Now, if it decays through alpha, 2 and 4, you need to remember this, 2 and 4 He, then you need to work out what the numbers are just here. So if it starts with 86, 2 lose, which leaves 84 protons remaining, and that then changes the element into polonium. We've got a mass number of 219, the mass number of helium is 4, so if that's left the nucleus, you're then left with 215, because 219, take 4, gives you 215. Now, you're not expected to remember any of this, but you are expected to be able to solve them. And to solve them, you'll need to recall that alpha is 42He. So the emission or release of an alpha particle will cause the mass number and charge to go down, just because this has a charge of +2. Beta particles look like this. So -1 underneath and 0 on top, and then E, and that links to the fast-moving electron that a beta particle is. Let's look at a different example. So this time we've got carbon 6 and 14, 6 protons and 8 neutrons add up to the 14 just there. In this case, it releases a beta particle, and then that's -1. This is the tricky bit that people get confused on. So 7 add -1 gives you 6. And then 14 take 0 equals 14. And again, you don't need to remember this, but you do need to remember that a fast-moving electron, or a beta particle, is -1 and 0, and that little trick here. So the emission of a beta particle does not cause the mass number to change. 14 stays at 14, but it does cause the charge to increase because we have an electron with a negative charge going away. So we've looked at alpha and beta. Gamma rays, as a reminder, is just a high-energy electromagnetic ray that comes from the nucleus. And because it's just a ray and not a particle, it does not cause the mass or the charge of the nucleus to change.